So, hello everyone again. This is lecture 5 part 2 of dual nature of radiation and matter. In the previous discussion on this topic, we were talking about Davisson and Germer experiment, in which we started with the introduction of what is this Davisson and Germer experiment. Today we will go on with the results and discussions about this topic only. So, let us start the discussion directly. I am Sameer Lavankar. Let us begin our discussion. Okay, so right now we are on the last topic of this lecture series, that is Davisson Germer experiment. Maybe by the end of this lecture we are done with this complete lecture. Okay, so Davisson and Germer experiment, these all things are already been explained in the previous discussion only. Let's move on with this discussion now. Okay, so the last part which I explained you in the last part, line was that the variation of the intensity of the scattered electrons with the angle of scattering theta. This is your angle of scattering theta, and this the variation of intensity is basically observed here. Either it can be higher, it can be lower, and this is how the voltage has been increased or decreased. Okay, for different accelerating voltages. Okay, next thing is the experiment was performed by varying the accelerating voltage from 44 volts to 68 volts. So, basically now we also have the range. So, what was actually happening, the voltage was being capped. Let us say the voltage is in the range of 44 to 68 volts. Okay. So, this has also been explained here. It was noticed that a strong peak appeared in the intensity I of the scattered electrons for an accelerating voltage of 54 volts at a scattering angle of theta is equal to 50 degrees. So, basically what you were trying to do, you were at 44, the angle. So, basically there were two different cases being observed. Let us say for the first case we are just taking the value of theta to be constant. We are taking the value of theta to be constant, we are just trying to vary the value of voltage. Let us say we are at 44, then we were at 45, then we were at 46, till we went on to let us say 53, 54, 55, then we went on to let us say 67, 68. Okay. Some value of theta was kept constant and we did the complete process now. Okay. Let us say that theta was, let us say that the complete range was, let us say 10 degrees to let us say 80 degrees. Okay. Then for 10 degrees we did the complete process, that was test 1. Then at 11 degrees we did the complete process. So, let us say from 10 to 80 degrees we had complete results like this. Then finally when we found out, when we tried to analyze the results, it was found that the intensity was maximum for the voltage equal to 54 and the theta is equal to 50 degrees. Okay. So, this was how maybe the experiment was being conducted. The appearance of the peak in a particular direction is due to the constructive interference of electrons scattered from different layers of the regularly spaced atoms of the crystals. Okay. For the basic concept of what is constructive interference, you may just go on and look to the wave nature of propagation. In that it is explained very in detail what is basically constructive interference, what is destructive interference. So, basically what is happening is there is a concept called as path difference, right. So, basically if the path difference is for the concepts of constructive interference, the intensity will be maximum, and if the path difference is such that it is of the order of n lambda by 2 or n plus 1 by 2 into lambda, then it is of destructive interference, and if it is destructive interference we can say that the intensity is 0. So, if the path difference is n lambda, then it is intensity is maximum, and if it is n plus 1 by 2 into lambda, then it is intensity is 0. So, that is how the definition of constructive interference and destructive interference came into picture. This has already been explained very clearly in the wave nature. So, you may just go and refer to those lectures. Okay, so the appearance of the peak in a particular direction is due to the constructive interference of electrons scattered from different layers of the regularly spaced atoms of the crystals. So, basically why it is happening that for some instances the intensity is maximum, for some it is at a lower stage. So, basically it is happening due to the path difference of the wavelength. So, how can we say that the intensity is being changing? Okay. Why was this experiment called as the experiment which produced or which discovered that yes, the radiation has a wave nature? we already conducted different experiments for the concepts of finding out what is constructive interference, what is destructive interference. If something is having a variation in the intensity, that means that there is a path difference. If there is a path difference, that means there is a wavelength associated with that particle. If there is a wavelength associated with particle, it is a very high, very high probability or a completely certain probability that it shows a wave nature of let us say propagation. That is how we can go to the result, or we can come to the conclusion that yes, these electrons also has a wave nature. So, because the constructive interference was happening, hence we can say that this is having a wave nature of propagation. So, the appearance of the peak in a particular direction is due to the constructive interference of electrons scattered from different layers of the regularly spaced atoms of the crystals. From the electron diffraction measurements, the wavelength of matter waves was found to be 0.165 nanometers. So, then another experimental detailed results were being research was being done and found out that the wavelength of matter was found to be 0.165 nanometers. Moreover, we can also see that this is of the order of similarly of nanometers only, hence it can be calculated. If this would have been, let us say we would have done the same experiment for let us say a big particle, let us say 150 gram particle etc., then as the amount of de Broglie wavelength which we already calculated was of the order of 10 to the power minus 34, then for it is highly certain that this experiment could not be calculated. Just trying to say you why we understood the previous discussion and so on. There is nothing related to mass of 150 gram etc. here. I am just trying to make you understand that why was de Broglie relation necessary. Okay. So, next is the de Broglie wavelength lambda associated with electrons for voltage of 54 volt is given as. So, just trying to do the calculation again, we are finding out that this is equal to 0.167 nanometers. Okay. So, experimentally this value was calculated as 0.165 nanometer, and by using de Broglie wavelength we got the answer equal to 0.167 nanometers, which is very close to the experimental result. Hence, this can also be said as a proof to the de Broglie relation, that is de Broglie relation is supposedly true for the experimental results also. It can be proved that de Broglie relation can be used, let us say for cases in which we cannot calculate or we cannot do the experimental results. So, this was also one of the conclusion here. Next is, thus there is an excellent agreement between the theoretical value and the experimentally obtained value of the de Broglie wavelength, quite evident. Davisson Germer experiment thus strikingly confirms the wave nature of electrons and the de Broglie relation. Okay. So, basically what were the 2 points of Davisson Germer experiment? The first point was it was quite clear that the wave nature of matter, the wave nature of electrons can be confirmed. How it can be confirmed? Because there was an difference in the intensity with the variation of the angle of scattering and the variation in the voltage. Please remember here variation in voltage is due to the accelerating voltage, which is this voltage being explained here. Okay. Next thing was so why it was confirmed, because as there was a constructive interference happening. Why was there a constructive interference happening? If there was a constructive interference happening, we can say that yes, there was a path difference, and if there was a path difference, there was a use of wavelength somewhat or the other, and if there is a wavelength, then we can say that yes, this radiation has a wave nature. De Broglie relation was explained how, when the particular experiments were being done more, it was found that the experimentally the wavelength value was calculated as 0.165 nanometers. Using the de Broglie relation, we did the same experiments again, we did the calculations, and we found out the value of lambda is equal to 0.167 nanometers. Because these values are very close to each other, we can say yes, that de Broglie relation can also be confirmed or can also be utilized in the further experiments or relations. Okay. Next is more recently 1989. So, now as you can see, this complete experiment was already being done in the era of 1927. After approximately 50 or 40 years, in 1989, the wave nature of a beam of electron was experimentally demonstrated in a double slit experiment similar to that used for the wave nature of light. So, basically this was the Young's double slit experiment, which we already explained or which we already learned in the wave nature of light. Okay. So, this is how, so basically as you can see the chronology. So, first of all Davisson Germer experiment was being done, then similarly at the same time G.J. Thomson also did his experiments, and after let us say 30-40 years this double slit experiment was being done. So, even before double slit experiment, this complete concept of constructive interference, destructive interference was already been in let us say in our surroundings. Okay. Next is also in an experiment in 1994. So, after approximately 5 years, interference fringes were obtained when the beams of iodine molecules, which are about 1,000,000 times more massive than electrons. So basically we can say that Davisson Germer experiment was the initialization or the first baby steps towards the wave nature of particle. The de Broglie hypothesis has been the basic to the development of modern quantum mechanics. So, quantum mechanics, as the name suggests, the mechanics of the quantum particles. It has also led to the field of electron optics. Electron optics, as the name suggests, using electrons to, let us say, to view very small particles, or let us say to view something, or to make optical instruments using, let us say, electrons, etc. It has also led to the field of electron optics. The wave properties of electrons have been utilized in the design of electron microscope, which is a great improvement with higher resolution over the optical microscope. So, as the name suggests, using electron optics, as in trying to find out or trying to discover or trying to make new microscopes which have a higher resolution, because optical instrument has a very low resolution as compared to electron microscope. These all concepts about optical instruments has been explained in the topic of your ray optics. So, please you can go and refer to those topics also. So, you can understand much more clearly what is resolution being talked about. Very small concept, but you can understand there much deeply. Okay, so that is a complete end of your dual nature of radiation and matter. Let us do a quick summary and then we can close the lecture. Okay. So, summary is the minimum energy needed by an electron. So, we started with the complete concept of why was there an electron emission happening, what is the basic crux of electron emission, how can the electron emission can be utilized in the day to day results. So, the minimum energy needed by an electron to come out from a metal surface is called the work function of the metal. Please remember these definitions, because these definitions can directly be asked in the exams. So, basically what is work function, etc. Energy greater than the work function phi naught required for electron emission from a metal surface can be supplied by suitably heating or applying strong electric field or irradiating it by light of suitable frequency. So, these all things were already also been explained using experiments, and we tried to find out what was happening here. Next is the photoelectric effect is the phenomena of emission of electrons by metals when illuminated by light of suitable frequency. Certain metals respond to ultraviolet light while others are sensitive even to visible light. So, I also explained you using a table that some of the metals have a very low value of work function and some has a very high value of work function. Okay. So, photoelectric effect involves conversion of light energy into electrical energy. It follows the law of conservation of energy. The photoelectric emission is an instantaneous process and possesses certain special features. Okay. Next is the photoelectric current depends upon. So, everything. So, these complete experimental data results were being explained, different experiments were being performed to find out what happens when the current is being changed, or let us say we keep the intensity constant, we keep the potential different constant, etc. So, these all things were already been explained. You can just refer back if you have any doubts regarding that concepts. So, photoelectric current depends upon the intensity of incident light, the potential difference applied between the two electrodes, and the nature of the emitter material. The stopping potential V naught depends on the frequency of incident light, the nature of the emitter material. So, basically stopping potential, we also explained what is stopping potential, we made 2-3 diagrams regarding that also, you can just refer that. Those diagrams are very important as far as your exams are concerned. So, the stopping potential V naught depends on the frequency of incident light and the nature of the emitter potential. For a given frequency of incident light, it is independent of its intensity. Please remember, this can come in your exams. So, for a given frequency of incident light, it is independent of its intensity. The stopping potential is directly related to the maximum kinetic energy of electrons emitted, that is EV naught is equal to kmax, and this is where we also use this formula for your de Broglie relation also. Okay. Next is below a certain frequency, threshold frequency, the characteristic of the metal, no photoelectric emission takes place, no matter how the large intensity may be. So, basically there is some little threshold frequency below which even if you try to increase the intensity, there is no photoelectric effect being happening. Next is the classical wave theory could not explain the main features of photoelectric effect. Its picture of continuous absorption of energy from radiation could not be explained using the independence of Kmax on intensity, the existence of V naught and the instantaneous nature of the process. Einstein explained these features on the basis of photon picture of light. So, this is how the concept of photon came into existence, as in because the complete theory of photoelectric effect could not be explained using the wave nature, hence we use the photon nature. Photon is basically a particle and and that is how the name came up, that is it is dual nature of radiation and matter. Okay. According to this, light is composed of discrete packets of energy called as quanta or photon. Each photon carries an energy E is equal to h nu and momentum p is equal to h by lambda, which depends upon the frequency of the incident light and not on its intensity. Please remember, it is very important point that it does not depend upon the intensity. Photoelectric emission from the metal surface occurs due to the absorption of a photon by an electron. Okay. After this, we also did some of the examples regarding the concepts of photoelectric effect, regarding the concepts of each photon, etc., amount of energy required for the n molecules so that the photoelectric effect can occur, etc. Next is the Einstein's photoelectric equation and is in accordance with the energy conservation law as applied to the photon absorption by an electron in the metal. The maximum kinetic energy half mv square is equal to the photon energy h nu minus the work function phi naught of the target metal. Hence, please remember, because numericals can be asked from this major, it is highly probable that questions can be asked from this topic only. So, basically half mv square is equal to ev naught, which is equal to h nu minus phi naught. Or we can say, if we convert phi naught into h nu naught, we can say that half mv square, basically kinetic energy, is equal to h into nu minus nu naught. Okay. Next thing is, this photoelectric equation explains all the features of the photoelectric effect. Millikan's first precise measurements confirmed the Einstein's photoelectric equation and obtained an accurate value of Planck's constant h. If you remember correctly, Millikan first tried to disprove the Einstein's photoelectric equation, but later he concluded by explaining the or proving the Einstein's photoelectric equation. Okay. So, this led to the acceptance of particle on photon description of electromagnetic radiation introduced by Einstein. Finally, radiation has a dual nature. So, the nature of experiment determines whether a wave or particle description is best suited for understanding the experimental result or not. So, basically I made you understand about the de Broglie wavelength. Then next was about the Heisenberg's uncertainty principle. Okay. And finally, it is that electron diffraction experiments by Davisson and Germer and by G.P. Thomson, as well as many later experiments, have verified and confirmed the wave nature of electrons. The de Broglie hypothesis of matter waves supports the Bohr's concept of stationary orbits. Okay. So, please remember the Heisenberg's uncertainty principle also, that is delta x delta p is approximately equal to h bar, and where h bar we can write it as h upon 2 pi. Okay. So, this is your Heisenberg's uncertainty principle, where delta x is uncertainty in the position and delta p is basically the uncertainty in the momentum. Okay. Finally, these are some of the physical quantities for which you need to remember, or you can just remember the symbols, the unit, because units are very much required as far as your numericals are considered. Okay. So, basically Planck's constant, please remember the concept Planck's constant, that is 6.6 × 10 ⁻³ - 34 joule second. The symbol used is H, unit is joule second, and this is basically used in E is equal to h nu. Used very everywhere, it is also used in de Broglie as lambda is equal to h upon p. Stopping potential is V naught, so voltage unit is V only, EV naught is equal to k max. Next is a work function, that is phi naught, for which we use joules and electron volts. Threshold frequency is nu naught, as the name says, it is frequency, hence it is measured in hertz. Next is your de Broglie wavelength, that is lambda. Wavelength is always considered in units of meters, and wavelength calculated as using the de Broglie relation, that is lambda is equal to h upon p or h upon mv. Okay. So, that is your complete end of the lecture series on dual nature of radiation and matter. We started with the introduction, then we went on to electron emission, then photoelectric effect, then experimental study of photoelectric effect, as in trying to find out what happens when there is a change in intensity, change in the stopping potential, etc. Then photoelectric effect and wave nature of theory, so as to find out that yes, the photoelectric effect can be explained using wave nature of theory, but there are some of the concepts which requires the use of photon, or let us say particle nature of light. Okay. Next thing is Einstein's photoelectric equation, that is kinetic energy is equal to h nu minus nu naught, h into nu minus h into nu naught. Okay. Next is about the photon, that is basically till here this was concluded that yes, a nature of radiation is a dual nature, that is it consists of particle nature also and a wave nature also. Then finally, in this we understood the concepts of de Broglie relation, Heisenberg's uncertainty principle, and finally it was concluded that yes, matter and radiation both have dual nature. It's just the fact that for bigger particles the wavelength is very less, and for smaller particles the wavelength is observed can be observed very clearly. But as the name suggests, from Heisenberg's uncertainty principle, the value of position can be certain or uncertain depending upon the value of uncertainty in the momentum. And finally, we explained the Davisson Germer experiment, which basically proved the wave nature and also proved the de Broglie relation. Okay. So, that is the complete end of the dual nature of radiation matter. Thank you for listening. So, thank you so much.